In this part, we are going to find the general solution of trigonometric equations. First, we take a sine curve. A horizontal line cuts the sine curve at different parts. If I consider this part as theta, then this point as usual is sine theta. Now I am going to find different values of the angles for which the sine of that angle is equal to the same value as sine theta. So if I consider this point, this point has the same value as this point, and this one has the same value, this and this and this. So I am going to find what are the angles corresponding to these points here. So if this angle, this distance is theta, then this is theta. Therefore this becomes, since this is pi minus theta, and this becomes 2 pi plus theta, and this point becomes 3 pi minus theta, because this is 3 pi and this is theta. This is theta and this is 4 pi, therefore this point will be 4 pi plus theta, and this is theta, therefore this will be 5 pi minus theta, and so on. This will be 6 pi plus theta, and this will be 7 pi minus theta, and we can continue like this. What we have seen here is, if we have the basic angle as theta, then there are more values for theta, which are pi minus theta, 2 pi plus theta, 3 pi minus theta, 4 pi plus theta, and so on. We can generalize these things. I can write this as n pi plus minus 1 power n theta. Just check writing the values of n as 0, 1, 2, 3, etc. Let's substitute n equal to 0 and check this. If I put n equal to 0 here, this is 0, and minus 1 power 0 is 1, therefore you get 0, you get theta, and you get this value. If you substitute n equal to 1, we get 1 pi, which is pi, plus negative 1 power 1, which is negative 1, and therefore pi minus theta, which is this angle. If I substitute n equal to 2, then I get 2 pi plus negative 1 power 2 theta, which is 2 pi plus theta, which is this angle, and so on. So this is called the general solution of trigonometric equation, which is sine theta equal to some value k. Here the k is this point. So if sine theta is equal to k, then sine pi minus theta is equal to k, sine 2 pi plus theta, sine 3 pi minus theta, and so on. They are all equal to k. So different values of the angles for which sine theta equal to k are these angles. In general, you can write them as n pi plus minus 1 power n theta, where n is equal to 0, 1, 2, 3, etc. and where the theta is the basic angle, which is between 0 and pi over 2, which is 90 degrees. So you first find out the first theta, which is between 0 and pi over 2, and then with this theta you carry on with the other angles. So the basic angle theta is between 0 and pi over 2, and with that we can substitute in this formula and find out all the other angles. Continuing like this to cos theta. Let me see that this is k, and if I consider this as cos theta, that is this as theta, which is less than 90 degrees. So this theta is between 0 and 90 degrees. So the next angle corresponding to k will be here, which is 2 pi minus theta. This is theta here, and this is theta here. Therefore this will be 2 pi plus theta. And if you come to the next point, here it is, this is theta and this is 4 pi, therefore this is 4 pi minus theta, and this point will be 4 pi plus theta. So this is 4 pi plus theta, and so on. This will be 6 pi minus theta, this is theta, therefore 6 pi minus theta, and this will be 6 pi plus theta, and so on. So when cos theta equal to k, and if theta is an angle between 0 and 90 degrees, that is pi over 2. And what are the different values theta can take? The first value theta can take was 2 pi minus theta and 2 pi plus theta. Let's check it once. You can see that it was 2 pi minus theta and 2 pi plus theta. And then the next values were 4 pi minus theta and 4 pi plus theta. And the next values were 6 pi minus theta and 6 pi plus theta. From this we can generalize very easily that the general solution for cos theta equal to k will be 2n pi plus or minus theta. It could be either plus theta or minus theta, but it is 2n pi, for which n ranges from 0, 1, 2, 3, etc. So when it is 0 you get the theta, when it is 1 you get 2 pi plus theta and 2 pi minus theta, and etc. This is the general solution for cos theta equal to k, where theta is the first angle you get between 0 and pi by 2. Continuing like this to tan. Let's consider this as k. Then this will be the basic angle theta between 0 and pi over 2. Then this will be theta. Therefore this point will be pi plus theta. And this point, as you can see, will be 2 pi plus theta. And this is 3 pi plus theta, and so on. So if you want tan theta equal to k to be solved, and if you can find out the first angle between 0 and pi over 2 as theta, then the general solution will be pi plus theta. We saw this 2 pi plus theta, 3 pi plus theta, etc. And therefore the general solution will be n pi plus theta, where n ranges from 0, 1, 2, 3, etc. So this is the general solution for tan theta equal to a value k. Let's come back and see what happens if this k was negative. That is, if we had the k in this place. This is negative k. And then if I draw the line like this, then we have angles here, 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 and here. This angle, if you consider this, if this is theta, then this angle will be pi plus theta. And this angle will be 2 pi minus theta. And this will be 3 pi plus theta, and this will be 4 pi minus theta. As you can see that for the odd numbers of pi we have plus theta, and for even numbers we have minus theta. When sin theta equal to negative k, then the general solution should be n pi minus negative 1 power n theta, for values of n ranging from 1, 2, 3, etc. If I substitute n equal to 1, I get pi minus 1 power 1 theta, which is pi plus theta. Let's go back and see if we had this. We had the first angle on the negative side as pi plus theta. And if I substitute n equal to 2 in this, then you get 2 pi minus 1 power 2 theta, which is 2 pi minus theta. And that was the second angle we got. And therefore this is the general solution when sin theta equal to negative k. So if we write it together, when sin theta equal to k, and if you are able to find the angle between 0 and pi by 2, now let me call this angle as alpha, then my general solution, all other thetas, will be n pi plus negative 1 power n alpha. And if the equation was sin theta equal to negative k, and if I could find an angle between 0 and pi over 2, and which will be the same as this, then the other angles will be n pi minus 1 power n alpha. Let's look into an example. For example, if I had k is equal to 0.7, which means this point is 0.7. My first step is to find what is the value of alpha which lies between 0 and pi over 2. The basic value will be alpha here. In order to find the basic value alpha for the equation sin theta is equal to 0.7, I will be using the inverse function technique. Theta will be equal to sin inverse of 0.7, which is equal to approximately 0.775, and this I call it as alpha because this is between 0 and pi over 2. and this alpha is always called the primary angle. So the first answer for sin theta equal to 0.7 is 0.775 radians. The second, third and fourth angles can be got using this formula. So the formula says theta, the other angle says n pi plus minus 1 power n alpha, substituting n values as n equal to 1. I get theta is equal to pi plus negative 1 power 1 alpha, which is pi minus 0.775. Pi value should be taken as 3.142 approximately, and this minus 0.775 gives you an approximate value of 2.4. This is an approximation. So this is the second angle for which sin theta is equal to 0.7. The next angle will be when n is substituted as 2. For this I have theta is equal to 2 pi plus negative 1 power 2 times 0.775, which is 2 pi plus 0.775. This answer, when you calculate with your calculator, will be 7.058 approximately. Therefore, this is the third angle for which sin theta is equal to 0.7. We can continue finding all the other angles if I start substituting n equal to 3, 4, 5, etc. Instead of k is equal to 0.7, if I had k equal to negative 0.7, the first step of finding the primary angle remains the same. We are not changing this 0.7 to negative 0.7 here. This is always taken as positive. Though the equation is sin theta equal to negative 0.7, theta, the first primary angle, has to be taken as sine inverse of positive 0.7 because the primary angle lies between 0 and pi over 2. And 0 and pi over 2 is the first quadrant, and all values in this quadrant are positive. Therefore, we are finding the first value as, or the primary value, with positive value of k only. As you can see it in the graph, if I have negative 0.7 here, and if we draw the line, the first value on this side is pi plus alpha, but not sine alpha. There is no value as sine alpha here. That means the primary value is not included in the set of solutions for this question. When k is equal to negative 0.7, the primary value is not considered as the set of solution. So the answers start only from when n equal to 1. And here the formula changes to minus negative n pi minus negative 1 power n alpha, means it changes to pi plus 0.75. Therefore, these values change. And the value of this will be equal to, if you continue so on, and this will be 2 pi instead of plus, this will be minus, and this will be minus, and so on. So therefore, the second angle will be 5.9 approximately. So the answer for sin theta is equal to negative 0.7 starts from 3.917, and the next value is 5.9, etc. And it does not have the basic value 0.775 as its answer. This can be done with cos theta and tan theta as well in the same way. You find the primary angle and substitute it in the formula which we have seen. When we come to cos and take the negative value of cos, say here negative k, then the values of the angles will be, the first angle is here and this will be pi minus theta, and this point will be pi plus theta, and the second point is here and this is 3 pi minus theta. Therefore, this is 3 pi minus theta or 3 pi plus theta, and so on. The next value will be 5 pi minus theta or 5 pi plus theta. So what we have here is pi minus theta or pi plus theta, 3 pi minus theta or 3 pi plus theta, 5 pi minus theta or 5 pi plus theta, and so on. As you can see that the numbers here are odd numbers. Therefore, the general solution can be given as 2n plus 1 pi plus or minus theta. When we go on to tan, and if this is taken as negative k, and the values of the angles are here, and the first angle will be pi minus theta, and the second angle will be 2 pi minus theta, and the third angle will be 3 pi minus theta, and so on. Therefore, the general solution is n pi minus theta when tan theta equal to negative k is the equation given.